All right, so at the top I kind of wrote the definition of what we're going to talk about today, but we're going to talk about what similar polygons are. Polygon's just a fancy word for shape. There's really two requirements here. So this is kind of like what we were doing with our congruents, but it's similar. So basically what you're going to have, same shape, but different sizes. All right, those are considered to be similar. So the two requirements, the two polygons, these are just both quadrilaterals here, are similar. Now, all the corresponding angles have to be congruent. So if you look at the two pictures there, like angle A and angle G are both right angles. Angle B and angle H are both right angles. Angle C here, single mark. Angle I, single mark. Angle D, double mark. Angle J, angle mark. So all the angles are congruent. So angles are equal to each other. Now, the part that's a little bit weirder about similar figures versus congruent figures, the lengths of all the sides, they're called that they are in proportion, or they are proportional. So here's how this works, and I'll show you these little fractions that they have set up. So side AB would correspond to side GH in the little bit bigger figure. You can, if we knew the side lengths, or if we just know the picture here, you put, and I should have grabbed a different color, but those two are set in a fraction together. So A over B AB over GH. Now, that would be equal to any of the sets of sides that are corresponding to each other. So like the next one, BH and HI. If I stacked those, if I knew the side lengths into a fraction, they would all reduce to the same thing. So then you got like CD and IJ. So that's the next one. So these are all equal to each other if we actually had numbers, which we don't have in this diagram. And then the same for AD and JG. They match with each other in the picture, so you can stack them into a fraction. Those would all be equal to each other. We'll do this with some numbers in a couple seconds in a different example, but that allows you to solve for missing sides using some proportions, which we're going to do in a second. And then before we move on, I just want to show you this. You'll see this today. It says here the diagram ABCD is similar to triangle GHIJ. This symbol, it's like just a little squiggly line. It's like what goes on top of the congruent symbol, but that is to stand for similar. So the two figures are the same shape but different sizes is basically what that means. That's what you have when you're similar. Okay, so you're going to just see some pictures, and it's going to ask you to basically match up the similar parts. So the angles have to be exactly congruent to each other. So I've got ABC, this says, is similar to triangle XYZ. I just have a couple things labeled, just a couple of angles. Could we figure out the measure of angle Z in this triangle based on what we already have in the picture? What do you think? Yeah, we know any triangle, doesn't matter, have to add up to 180. So 42, 78, if you just do 180 and subtract both of those guys, you should get 60. Yeah, I just heard somebody say that. So angle Z would be 60. They're not exactly the same. That's congruent, so similar. So they're going to be the same shape but different sizes. The angles will all match up, but the sides are going to be in proportion. We're just going to do that here in a second. Okay, what would you tell me the measure? I don't have anything labeled in this little bitty triangle here. What would you tell me the measure of angle B is if I know these two triangles are similar? So all the corresponding angles have to be exactly congruent. So if I know that these two triangles are similar, what would you tell me for angle B? Exactly. So do you guys see, like, B and Y are in the same spot? So if Y is 78, B is 78. What would you tell me for angle A? Go ahead, Bryn. 42. They're just going to match up. All right. Now, the sides are a little different. We can't actually have any numbers here, but we can set up proportions. So if you want, I'm just going to color these real quick. So AB is going to go with XY. AC is going to go with XZ. And then BC is going to go with YZ. Sometimes if I color stuff, it's a little easier for people to see. All right, so in the drawing, if I say BC, I've just colored that green in mine. is in proportion to this. So I have BC over YZ. What would you fill in the blank here is what it's going to ask you to do. So BC over YZ would be what segment over XZ, which is, it's yellow in my paper. What segment would that go with? AC. Okay, yes, good. AC. So both the yellow ones go together. All right, so if I tell you AC, that's the yellow one, over XZ, that's the yellow one. I'm looking at number 5 here. So AC over XZ would be blank, which segment, over XY, which is the purple one in my paper. AB, exactly. All right, and then I got one more. Where's XY? XY is this purple one. AB is this purple one. And then it says YZ over what? BC. Okay, and you guys, it doesn't matter as long as you're consistent. These first two that I gave you, I had the smaller triangles sides on the top and the larger on the bottom. When I did this last one though, I had the larger sides on the top, the smaller sides on the bottom. As long as you're consistent, you can set these up in different ways. So basically on the top, these should both come out of the same triangle, and the bottom, these should come out of the same triangle, but you can flip them over. Okay, now I'm going to have you do this. This is very similar to the very first question on the homework assignment. So I'm just going to give you 2 triangles in a picture, and it says they're similar to each other. So this works like a congruent statement where the corresponding parts are going to match up. So this says CAB, so this guy here, excuse me, similar to WVT. So a little weird because one of them's kind of rotated around. But I want to list the corresponding angles. I don't have any angle measurements or side lengths here, but I can match up the corresponding parts. So if I tell you I'm going to look at angle C, which would be right here, which angle would that correspond to in the other picture? Exactly. So it's just asking you to list these out. All right, so let's say we looked at angle A. Which angle would that go with? V, good. All right, and I'm just putting marks on these in my picture. You don't have to do that. Which angle would B go with then? T. All right, so we're just matching up. So angles have to be exactly equal. Now, when you do the sides, they are in proportion to each other. So I'm just going to kind of try to color this to make it a little bit easier to see. If I looked at side C to A, that would match up with the side from W to V. So if you are in proportion, you can put those 2 segments into a fraction together. So that's what I'm going to do just real quick. I'm just going to put the bigger one on the top here. So I'm going to put AC over WV. Now, if these are similar, these all have to be equal to each other. If we actually had numbers, which we will in a second, then we can actually check. A to B would go with T to V. So then I can write another step to this proportion here. I'd say AB over TV. These would all be equal to each other if we actually had numbers in this. And then the last set, CB, that side is going to go with WT. So I'm just say CB WT. And as long as like all the top numbers are from the bigger triangle, all the bottom numbers are from the smaller triangle, as long as you set them up consistently, those fractions would all be equal to each other. Now, we're actually going to look at some that have some numbers. So I've got a little example here. Basically, when you put these sides in proportion, they call it the similarity ratio. It's basically what these are going to reduce to. So this, this relates corresponding sides in similar, I'm just going to abbreviate using that symbol, relates corresponding sides in similar polygons. All right, now, if you're going to actually write the similarity ratio, I'm just going to write that you might need to reduce, and that'll make sense hopefully in 1 second. So I've got 2 triangles here. All the angles that are corresponding are already marked congruent in the diagram. To show that the sides are in proportion, literally all you're going to do is match up the numbers from the corresponding sides. Okay, now this is just my recommendation because it doesn't tell you one way or the other. I usually put the smaller number on the top. So like this side with the 6 corresponds to this side with the 15. Now, if I reduce that fraction, that'll be my similarity ratio. So 6 over 15, both of those numbers, let's see, divisible by 3, or you guys could do this in your calculator. If you use your fraction key on your calculator, you can convert it just by typing it in using that. If you don't know how to do it, I will be happy to show you. But this should reduce to, let's see, these are both divisible by 3, so this would be 2/5. Now, any set of sides here that I choose that correspond to each other, as long as I set them up the same way with the smaller number on the top, the bigger number on the bottom, they should all reduce to the same thing. So the 10 and the 25 go together. If I do 10 over 25, both those numbers are divisible by 5, right? So if I reduce that fraction, that would also be 2/5. Now, if you're checking this, you have to check all the sets of corresponding sides. So I've got 2 sides that I checked, so I'm going to do one more. The 20 and the 8 go together. So if I do, I'm just doing the smaller number on the top, the bigger number on the bottom to stay consistent. If I do 20 over 8, both of those are divisible by 4, and that one is also 2/5. If they all reduce to the same thing, that's showing that those sides are all in proportion because they all have that same fraction. That number here is 2/5. That is your similarity ratio between those two triangles. So if you're checking this, they all have to reduce to the same thing. If even one of them is not doing that, then you're done. Anybody having a question about what the similarity ratio is? Okay, so you guys see problems like this. They'll give you 2 pictures and they'll say, okay, are these similar? So the first thing we should check, do all the corresponding angles have congruent marks, or could we mark them congruent? So like here, C and F are congruent, A and D, they marked it in the picture, B and E. Okay, all these are congruent. Now, I don't know that they're similar, so I got to check the sides to see. So, excuse me. If I'm not sure, I literally just look for the smallest number in each triangle. So the smallest number here is 8. The smallest number here is 10. So those would have to match up if these were similar. And then the biggest number here is 16. The biggest number here is 20. So those would have to match up with each other. And then the 2 that are left over, I've got 12 and 15. What we're going to check is we're going to see if I put these into fractions, do they all reduce to the same thing? All right, so I would just recommend put the smaller number on the top, bigger number on the bottom. Most of the calculators that you guys have will just do that for you if you use the fraction key. And if you want me to show you how to do it, I will be happy to do it. If anybody's borrowing one of my graphing calculators, there isn't a fraction key on here. So like if I was doing 8/10, I just do 8 divided by 10. That'll give me a decimal. And I just hit, I don't know if you guys can see this, there is a button. It's the 4th one down. It says math. If you hit math, and then that very first thing will convert this into a fraction on the screen, it looks like this. Just hit enter twice, and it'll convert it to a fraction in lowest terms for you. So this is 4/5. Or you could do it by hand. It's up to you. Both of those numbers are divisible by 2. I got to check each of these sets of sides to see if they reduce to the same thing. So I'm just going to set these up. It doesn't matter the order you do them in. So I just did the 8 and the 10 first. Now, 16 and 20 go together. So I'm going to put 16 over 20. And those are both divisible by 4. So this is also 4/5. So far this is looking good, but all the sets of sides have to be in proportion. And so I got one more set to check, which would be the 12 and the 15. And if I reduce that, both of those guys are divisible by 3. So this, yep, this is also 4/5. Okay, now, if they are all the same, we just showed that, they all go to the same number, so those 2 triangles are similar. If you want to write a similarity statement, it's like a congruent statement. We're just going to match up the parts that are similar. I'll call that first triangle, I'll just call it ABC. And then just instead of a congruent symbol, you just put that similarity symbol in between. All right, so if I call my first one ABC, I have to call my second one DEF to match up the corresponding parts. That's your similarity statement. The similarity ratio, I'm just going to write SR for similarity ratio. That's that fraction, whatever that reduced to, that's your similarity ratio. That's the ratio between the fractions. You could also see that written, like they might say something like 4 to 5, like that. Might see that as well. Okay, so these are similar. So we're going to check these two. First thing you should check is the angles. All right, so I've got an 80-degree angle and a 43-degree angle, 70 and 63. I'm just, at least, let me find the third angle in at least one of these triangles real quick. If I, don't worry about that for the moment. We're going to check the angles first. I'm going to figure this out real quick. 180, I've got one angle that's 80, one angle that's 43. So then where I have angle E there would be 57. Okay, corresponding angles have to be congruent for these two to be similar. Do I have corresponding angles congruent here? No way. Like this is 80, this is 70, this is 63, this is 57. I'm not even doing anything. Bless you. Those angles don't match up, so they're not similar. All the corresponding angles have to be exactly equal to each other. If they're not, I wouldn't even test the sides there because I can tell from the angles that these are not similar. Okay. Now, in the next picture, all the corresponding angles are marked congruent. So right angles, and then I've got curves on these. If I was going to go through and check the sides, they have to all reduce to the same fraction. What I would show you right here, like, I don't know. So this one's 24, this one's 14, right? So I could put that into a fraction, 14 over 24. What I would draw your attention to right away, this segment and this segment are both 6. Are these similar to each other? No way. Like this side is way shorter in this diagram than it is here. So I would not even go through. The angles are all good here, but I can tell just from looking at that, if I put that into a fraction, that would just give me 1, whereas all the rest of these, if we'd put them together, would give us some kind of fraction we'd have to reduce. So right there I can tell that's a problem. These are not going to be similar because the sides are not going to be in proportion. All right, what about this last picture in this example? Do you think these are similar just looking at it? We got all the angles would match up, right? What if I started putting sides together? Would that, like if I went around here, would these all reduce to the same fraction if I put them together? Yeah, every single set here, one side is 4, the corresponding side would be 6. So I wouldn't check this 4 times, right? Because it's the same thing every time. Every single one of these would be 4 over 6. Those would all reduce to 2/3. So that is your similarity ratio, if it asked you for that. And then your similarity statement, I don't have a special symbol since this is a quadrilateral. We'll just have to use all 4 letters. So I would say like A, B, D, C is similar to D, E, F, G. Just something like that. All the angles, we got them checked off there. They're marked in the picture. Every single one of those sets of sides would be 4 over 6, which would reduce to 2/3. Okay. Does anybody have a question? All right, now. This example is where we're going to use some proportions. So bear with me to see if we can set these up. So it says the polygons, so the 2 shapes in the picture are going to be similar to each other. Find the value of the variable. Here's what you want to do. You've got to find a set of sides where you know numbers for both. All right, so like if I look, like the 12 and the x would go together, the y and the 6 would go together, z and 3.5. The only set of sides where I know numbers for both are these two, so the 9 and the 6. All right, and you can literally use this to find all the missing variables in this lovely problem. Totally doesn't matter as long as you're consistent. I'm just going to put the smaller number from the smaller figure on the top and the bigger number on the bottom. So I'm going to write 6 over 9. All these sides have to be in proportion. As long as you're consistent, we could all do this a little differently. I'm just putting the smaller number on the top, the bigger number on the bottom. You can reduce that or you can leave it alone. I'm just going to leave it alone because it's less work. All right, let's say I wanted to find x. So all these sets of sides have to be in proportion, so I can set up a proportion. So if I write 6 over 9, what could I set that equal to find x? So if I go 6 over 9, how do I have to set up the other side? Okay, so if I wrote 6 over 9, and then you said 12 over x, you know what would be wrong with that? It has to be, I know this is super tricky. So like I did, like both of these are from the smaller figure and both of these are from the larger. As long as you're consistent. Like if you wanted to do 9 over 6 and then 12 over x, that would work. Does that make... As long as you're consistent. If you reduced it, yes, but the x would still be on the top and then the 6 would be on the bottom. You could do that. You could reduce it. You could do it like that. But like, so this, see how these two are from the same figure, and then these two are from the same figure. So these need to be on the same part of the fraction. So I'm literally just, I'm taking one here. I'm doing 6 over 9, x over 12. Does that make sense? I know it's weird, but you got to match up the same parts. Or the same parts of the fraction have to be from the same figure, if that makes sense. Like the 6 and the x are both in the smaller one, the 9 and the 12 are both in the bigger one. And as long as you match that up, you should be okay. There's different ways to do these, but as long as your cross products were the same as mine, you should be good. So if we cross multiply here, you get 72 equals 9x, so x is just going to be 8. Done. Okay, now if I want to find like y, I can use that exact same thing, just 6 over 9. And then y is going to go with this side that says 6. All right, so I said 6 over 9, so I did smaller, larger, so I have to repeat that. So it would be smaller, larger, it'd be 6 over y. And you guys might be able to tell that right there without doing a cross multiplication. The tops are both 6, right? What does y have to be? 9. Now, if you actually do go through and cross multiply that, 9 times 6 is 54, 6 times y, 6y, divide that, you'll still get 9. But if the tops both match, the bottoms have to both match if you're setting up. Nope, how would you do it differently? You can do it that way too. If you want to reduce it first, you can definitely do it like that. You can definitely do it like that and use the similarity ratio. I usually just use the numbers from the picture because it's a little easier for me to remember because I can look at it. To get z, do the same thing, 6 over 9. Then I would have to set that up. So if I do 6 over 9, then I have to go back to the smaller one, do 3.5 over z. And then I'm just going to cross multiply real quick. So I'd have 6z, and I think this one's not a nice number. If you do 9 times 3.5, you get 31.5. And then I'm going to just divide that by 6 real quick. So z is going to be 5.25 there. So some of these might be nicer answers than others. Okay, I'm going to do 2 more with you. I'm going to skip the very last problem to give you some more time to work on the homework. But I definitely want to do this question here. Now, you want to find a set of sides where you have numbers for both. So here I would tell you the 15 and the 30 are corresponding sides. Now this is tricky because this is twisted in the middle, if that makes sense. Which side would go with the x? Would it be the 25.5 or the 37? Good. Okay, so this is tricky, but that would go there. And so then the other set of corresponding sides, the 37 and the y. Completely up to you how you want to do this. Because you can reduce, but I would put the 15 and the 30 together. These have to be in proportion with all the other sets. If you want to reduce that to 1/2, you can. If you want to leave it alone, you can. It's up to you. So if I do 15 over 30, and then I want to find, let's say, x. If I do 15 over 30, then I'm going to do x over 25.5. And I'll just do it in my calculator in a second. If I want to do y there, I'm going to use that 15 over 30 again. And then I would have to do, if I do 15, that's from the smaller triangle, over 30, the bigger triangle. Then I have to go back to the smaller triangle, which would be y, over the corresponding side, which would be 37. So I'm just setting it up. So in the top, both of those are from the smaller triangle. In the bottom, both are from the larger. Within the same fraction, you're putting together corresponding parts. Okay, so for x, I'd do 15 times 25.5. And I would get 382.5 equals 30 times x. So then to get my x, I'm just going to divide by 30. So 12.75 for that guy. And for y, if I do cross products, I'm going to do 37 times 15, which is going to give me 555. The other cross product is 30 times y, and we're just going to divide that by 30. So y there, 18.5. And I just want to do one more with you because each of these is just a little bit different. I'll skip this last one. If you guys want to do it for some extra practice, you can, but that's okay if you don't. You will sometimes see figures here where there's kind of like almost one stacked inside the other. So like there's like a little bitty triangle here, and then there's like an overall triangle here. What I would recommend if you get a problem like this is to separate those two things. So I'm just going to redraw the little yellow triangle and just label any of the sides I can. So this is X, this is Y, this is 5. These are similar to each other. And then I'm going to draw that bigger triangle. I kind of outlined it in pink on mine. This whole side across the top, they tell you, is 8. This whole side across, or down this, going down this way is 6. And then this whole side here is 10. And usually if you separate them, it makes it a little bit easier to do the problem. So you're looking for a set of sides here where you know numbers for both. So I have 5 and 10. So I can use that to set up any of the proportions I want to do here. The X and the 8 would correspond to each other. And let's see, the Y and the 6 would correspond to each other. So basically I just have to do one proportion for each variable. The set of sides where I knew both were 5 and 10. Again, you can reduce that to 1/2 or you can leave it alone. It's up to you. I'm just going to leave it alone so you can see the numbers from the picture. If I do 5 over 10, and let's say I wanted to find X, I would have to do X over 8 to set that up correctly. The top numbers both come out of the smaller triangle. The bottom numbers both come out of the larger triangle. To find Y, I would use that 5 over 10 again. All the sides have to be in proportion, so these would have to reduce to the same thing if we were checking for similarity ratio, or they have to be equal to each other like this if we're trying to find a variable. So if I do 5 over 10 for Y, I would have to do Y over 6. And then both of these I'm just going to solve real quick, cross multiply. 5 times 8 would be 40, 10 times X would be 10X. Divide by 10 there, X is just going to end up being 4. And then this guy cross multiply here, 5 times 6 is 30, 10 times Y is 10Y. Divide by 10 there, and Y will be 3. Once you set these up, they're usually not too bad to solve. It's just the process of kind of matching up the corresponding parts.
Common